Okay. New chapter. Now, chapter 12 is kind of a whole bunch of really weird things, but they all have to do with sequences and things going in order, adding up things going in order. They're all kind of along the same line. So this first stuff is pretty easy. It's just a whole bunch of little things all thrown together. So sequences, if I want to write the first 6 terms of this sequence, now this one is in formula form. So the n just stands for the numbereth of term. Right? So if I want to find the first term, I plug 1 in for n and it'll tell me what the first term is. So if I want to find the first 6 terms of this sequence, I just start plugging things in for n. So my first term will be what? In other words, a sub 1. Okay, so a sub 1, if I plug 1 in there, what will I get? 0, because I'm going to get 0 over 1, which is 0. If I sub in, so if I plug in 2, what will I get? 1 half. I get 1 over 2, so I get 1 half. Third term? Thirds. Fourth term? A sub 4 is 3/4. A sub 5, 4/5. A sub 6, 5/6. So my first 6 terms will be 0, 1 half, 2/3, 3/4, 4/5, 5/6. If I had to keep going, I just put the triple dots. That just means that pattern is going to continue. Right? So if I wanted to write the first 6 terms of this sequence, right, we just plug things in for it. So what will my first one be? 2, because if I plug in a 1 here, I'm going to get 1 plus 1. So I end up getting a negative 1 squared, which is positive 1, times my 2 over 1, so I'm going to get 2. What will I get if I plug in my second one? Negative 1. Because if I plug in the 2, all right, 2 plus 1 is 3. So I'm cubing a negative 1, which is still negative 1. All right, so I'm going to end up getting a negative. If I plug the 2 in here, I'm going to get 2 over 2, which is 1. All right, so if I plug in 3, will it be positive or negative? Positive. So you kind of see how this is going to be oscillating between positives and negatives, right? So when you're writing your own formulas, which is coming, right, if you need it to oscillate in between positives and negatives, this is a good way to go about it. Take whatever your formula is, multiply it by negative 1 raised to the n plus 1, or even the n minus 1. That works too. All right, so if I plug in 3, I'm going to end up getting a positive, so I don't really have to worry about this part anymore. And that's going to get me positive 2/3. So when I plug in the 4, negative, right? 1 half. Fifth term, positive again. 2/5. And sixth term, negative again. 1/3. Right, so those are my first 6 terms. All right, this is kind of a weird one. I don't even know that I do this in the homework, but I threw it on here just in case it shows up somewhere. I know I don't do it on a quiz, but where you have like an if statement. It's almost like those piecewise functions that we did. All right, so if I want to find the first 6 terms of this one, it's going to be n if n is even, and it's going to be 1 over n if n is odd. So my first term, 1, so it's odd, so it'll be 1 over 1, which is 1. My second term will be 2, because it's even, so it falls into this category. My third term, third, my fourth term, my fifth term, my sixth term. Okay, so that's kind of a weird one, where it falls into this if-then type thing. All right, factorials, you guys have seen these before. So when we have an n with an exclamation point, that doesn't mean n. Woohoo! No, it means n factorial, which you take whatever n is and you multiply it by all the whole numbers all the way down to 1. So basically, this is showing this here, but you guys have seen these before, correct? Okay, so whatever n would be, then I would multiply that by 1 less than it factorial, which means I would multiply that by 1 less than it factorial, 1 less than it. So basically, if it's 5, it's going to be 5 times 4 times 3 times 2 times 1. Right, so 2 factorial, that really just means 2 times 1, which is 2. 3 factorial, 4 factorial. So you can see that the factorials actually get pretty large pretty quickly, just because you're taking whatever you had before and multiplying it by the next number up. So they will increase fairly largely. All right, so writing a sequence. Now these are a lot harder than they look. Most people are really good at picking out the pattern, but then trying to write that pattern in terms of ends so that it works, not the easiest thing to do. Warning, I am awful at these. I'm very non-abstract. Well, I can do them. I just need a lot of time. These ones I've done several times before, so I already know how they work. But you guys will probably, most of my students actually pick up on it pretty quickly. You guys are much better at abstract things. I am very linear and visual, so I am awful at these. But given enough time, I can always sort them out. So we want to, you see what the pattern is going from here to here to here to here? What's happening every time? We're actually multiplying everything by 1/3. So I want to come up with a pattern for that. So, and it has to work so that when I plug in 1 into my formula, I get 1. When I plug in 2, because my second term is 1/3, I get 1/3. So we need something with ends in it so that it works out that way. It's a little bit more difficult than it looks. What do you think? Any guessing or experimenting?
Let's say something along the lines of, is it n, or what's the symbol for number? The stuff at n.
Oh, just my sequence? You can pick whatever, so we could say sequence sub n.
Right. Equals sequence sub n minus 1. Right.
Okay, what do you want over here? You want a 1/3?
No,
Times what?
I want a big Sn.
Okay.
And then
No.
I want a big, alright.
I can only use n's.
Yeah.
Okay.
Wait.
No s's.
Oh, alright.
You say n minus 1 times 100.
N minus 1, like this, times 1/3. If I plug in 1, I will get 0 times 1/3, so that my first term should be a 0. Okay, so that's how. All right, but you're not far off. Are we agreed that there has to be a 1/3 in the problem?
Yeah.
Okay. Now we know the top just keeps staying 1, right? Okay, so I don't really have to deal anything with that, so I really just have to do something with the denominator. 1/3n. It's not bad. It's not going to work though, because if I plug in, I have an n here. If I plugged in the 1, I would get 1/3, but that's actually my second term. All right. So it looks like it might work, but then even when I plug in 2, I would get 1/6. Notice anything else in common with these 3 numbers? 9 is 3 squared. What's 3 to the first? What's 27? 3 to the third. But this is my 4th term. The squared one is my 3rd term. 3 to the first is my 2nd term. So what should I do to this down here?
For the
To the n minus 1. Try that. So when I plug in 1 here, I'm going to get 1 minus 1 is 0. 3 to the 0. 1/1 is 1. By second term, I plug in 2. 2 minus 1 is 1. 3 to the first. 3. 1/3. 1/3. Right? When I plug in 3, 3 minus 1 is 2. 3 squared is 9. 1/9. That's my 3rd term. It works. Okay? So these formulas kind of look a little bit more complicated than they first appear like they're going to be, right? But for me, it's usually kind of guess and check. Although you will notice, like, try to look for patterns like this where you have the squared thing. That's like a quick teller that the formula is going to have a variable in the denominator, the exponent. All right, so that's what we'll use for this one. All right, Now here's one that looks fairly simple. Write the formula for this sequence. 1, 3, 5, 7, 9, 11, 13, 15. Okay. So you say n.
No.
No. 1 plus 2.
1 plus 2n. So my first term would be 1. If I plug 1 in there, I'll get 2 plus 1, that's 3. That's actually my second. Times 2n minus 1. Okay, if I plug 1 in here, I'll get 1 minus 1, which is 0, times 2 is still 0, plus 1, that's 1. If I plug in 2, 2 minus 1, 1 times 2, 2 plus 1 is 3, that works. My third term, I would get 2 over here. That's going to give me 4, plus 1 is 5. Yep, so if you wrote it out that way, or even if you distributed and put things like terms together, so 1 plus 2n minus 2, that's 2n minus 1. That's probably the simplest thing. Okay, but I would take either one of these. This is acceptable. This is better. Okay. All right, how about this one? Take this sequence. All right, what do you notice is happening in this one?
Negative 1 plus something.
Right, because we have the, it's oscillating between positives and negatives, so we have to make sure that that works out. So I know that I'm going to have a negative 1 to the n plus 1 worked last time we did that. Now, if I take that to the first, what am I going to get, positive or negative? Positive, because it's going to be a negative 1 squared, which is positive. Did I want to be positive first? Yes. Okay, so I know that that's going to work. Times, yeah, this was kind of an easy one because they're just increasing by 1 over n. Because my first term would be 1 over 1 times this will make it positive. Right? So if I plug in my 2, that'll force this thing to be negative. It'll be negative 1/2. That's what I had. If I plug in 3, now this thing will be positive again. That's what my third term is. And it'll be 1 over 3, so it works out. So this is going to be my sequence for this one. All right, not too bad. Okay, summation notation, which is fun to say. Right, all this is saying, you just have to understand what it is it's trying to tell me here. So they're saying that I'm supposed to start k at 1. Right, I'm taking the summation, which means I'm adding up all the terms that I'm going to be using here. This is my formula, and I'm supposed to stop at 10. So what this is really saying is I'm supposed to take this and go, all right, this is 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4, plus all the way up to 1 over 10 is where I get to stop. That's all we're doing. Right, so for this one, my new formula here is K. Now it's K factorial. So I have to add these up. I'm starting at 1, but I'm ending at n. So what's that mean? When will I end? I'm never going to end. Right, so I'm just supposed to add them all up. So this is going to be 1 factorial plus 2 factorial plus 3 factorial, all the way up to n factorial. Right, so summation just means you're adding up all the terms. All right, there are rules on this. Right, you got properties and you got formulas. And I know this looks a little overwhelming. You will have this sheet on your quiz. I don't know. To be honest, I'm sure you won't take it. I'm not even sure that these guys will take it. But you'll have this at your disposal. And really, it's not all that overwhelming. Let's look at the properties first. All this is saying is that if I have a constant times some type of formula, I'm allowed to bring that constant out in front. So I can find the summation of the formula, and then whatever I get there. So let's say that my formula is just K. All right, so that's going to be 1 plus 2 plus 3 plus 4. Right, it's going up to some term. So I add all those up, right, and then whatever my constant was out in front of it, once I get my sum, I just multiply it all by that, and that's what I get. All right, so you're allowed to move the constant out in front. Here, if I have 2 formulas being added, You can break it up so that it's the summation of the first one plus the summation of the second one. Likewise, if you have two little formulas that are being subtracted, you could break that up into summation of the first one minus the summation of the second one. And then this one will be more, this will be easier to explain if we actually use numbers. What this one is saying is, let's say I don't want to start at 1. I want the summation of the terms from the 5th term to the 10th term. Right? All this is saying is that I want to find the summation of all the terms 1 through 10, but since I only wanted 5 through 10, then what do I have to take off? You take off the first 4, so 1 through 4, right? So it's kind of like those area problems where you have like the circle and the little circle in between, and you want to find the area of the space around here. You find the area of the big thing, you find the area of the little thing, and then you subtract them. Right? So that will get you the area of the donuts. I have to speak Eddie's language. All right, let's take a look at these formulas. They're not that bad either. If I have, this one says, if I have the summation of starting at 1 going to n of just a constant, all you have to do is take the n times the constant, and that's what your sum is going to be. So that one's pretty easy. These, if I have the summation of just a plain old k, I could substitute this formula in for it. If I have the summation of a k squared, I have to use this more complicated formula. If I have the summation of a k cubed, I could use this one or this one. They're the same. It's just one simplified. You'll have those two. Take them on a quiz. You'll be able to use them in your homework tonight because they're just on a sheet. I would suggest printing this thing out for yourself when you guys get home, just so that you have it right next to your homework. It will be on the website. I mean, the notes will be. Yeah, I would just print it off. Page, whatever, 4. All right, so let's look at some of these examples, and you'll see that they're really not that bad. All right, so I want to find the summation of starting at 1, ending at 5. Right? Now, I started you out with some really small numbers, so if you really wanted to do this one by hand, you could. So what this is really saying is I would have to go, all right, my first term would be 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. That's really not that bad because I had you ending at 5, right? You can just multiply those out, add them all up, and see what your sum is going to end up being. Right? So I'm going to get 15 plus 12 plus 9 plus 6 plus 3, 45. Okay. Now, that is not terrible. But if I made this going from 1 to 105, now all of a sudden I don't want to do that anymore. Right? So they come up with all these little formulas. There's insects in here. Tomorrow needs to run a cleaner shift.
Yeah.
All right, so now I can do a couple different things here. First, I can use the properties that I gave you guys. All right, what's a property that I can use here? I don't know. I think there's more than one.
There's more of them.
All right, what's a property that I can use first? Calculated property. All right, what am I allowed to do? I'm allowed to bring this 3 out in front, right? So I can really have the summation from k, when k starts at 1 and ends at 5, of just k, and then whatever I get when I do this, I'm going to multiply it by that 3. All right? So that makes it a little bit easier, right? Because it's going to be 1 plus 2 plus 3 plus 4 plus 5 now, right? But if I was going a lot bigger than 5, I really wouldn't want to add them all up, especially if I was going to like 3005. That would be terrible. So that's why they gave us those little formulas. When I have the summation of something and when it's just a k, right, we come back here, we have a little formula for that. It's n times n plus 1 over 2. N times n plus 1 over 2. What's n? 5. Right, so I'm going to get 5 times 5 plus 1 over 2. That's 5 times 6 over 2. That's 30 over 2. That's 15. Times the 3 that was out there, that's 45. So you end up getting the same thing as if you would have added them all up. Now that seems like more work when I'm only going 1 to 5. That is a lot less work when I'm going 1 to 3005. Right? All right, so let's take a look at this one. What can I do for your daring?
Yeah.
All right, what can I do for this one? What's the first property? Okay. What property should I invoke first for that one? I'm adding two things, so I'm allowed to break it up as two summations. So I'll have the summation, k to the third, plus the summation of 1. Now this one is the easy one because it's a constant. So what do I do for that? It's c times n, right? So my constant times the n, so what am I going to get for this one? 10. Right, so whatever I get here, I just have to add 10 to it. Right, for this one I definitely want to look back at that formula, so k cubed is this thing, so n squared times n plus 1 squared all over 4. So it's going to be n squared times n plus 1 squared all over 4. What's n in this case? 10. So I'm going to have 10 squared times 10 plus 1 squared over 4. That's 100 times 11 squared over 4. Well, these will cancel, and I'll get 25 times what's 11 squared?
121.
121.
A lot.
Plus 10. So what is 25 times 121? Is that before you or after you add the 10? 3,025 then, plus 10, so total 3,035. Plugging it in that formula beats going, all right, 1 cubed plus 1, plus 2 cubed plus 1, plus 3 cubed plus 1, all the way up to 10. Okay, but plugging it in the formula is much better. All right, this one's going all the way up to 24. Let's at least get this one set up, but we don't have to go all the way through it. What do I do here? First step,
Split it up.
break it all up. So I'm going to have the summation from 1 to 24 of k squared minus,
7 summation.
right, because you can bring that 7 right out in front, okay, plus
48.
summation 24, 2. You're right. This is going to be 48. This one is going to be 7 times n plus 1 over 2 minus, this one's going to be, I forget that one, n times n plus 1 times 2n plus 1, n times n plus 1 times 2n plus 1 over 6. Right? What am I plugging in for n in the first one? So it's going to be 24 times 24 plus 1 times 2 times 24 plus 1 all over 6 minus 7 times 24 times 24 plus 1 all over 2 plus 48. I will take your word for that. All right, but if I had to simplify by hand because I didn't have a TI expire, all right, so I would have a 24 times 25. This is 48 plus 1, that's 49 over 6. This will cancel with that and leave me with 4. 4 times 25 is 100. 100 times 49 is going to be 4900 minus. Over here, this one will cancel with that and give me 12. This is 25. 1225 is what? Yep. This quarters would be $3. So 300 times 7 minus 4100 plus 48. That's not terrible. That's 2800 plus 48. 28, 48. Is that what you said? See how these work? All right, one more. Now you'll notice this one. What's different about this one? Yeah, it doesn't start at 1. So this one's kind of a weird one. This is one of those area type problems where you have the donut. All right, you want to find the area of the whole thing, find the area of the thing that you don't want, subtract them. So that's what we're doing here. All right, so what I want to do, first thing I'm going to do is pull out that 4 out front. All right, and I'm just going to work inside my brackets here. whatever my end solution is going to be, I'm going to multiply it by 4. All right, so here, I want to find out what the total from 1 to 20 would be, and then what am I going to subtract off?
5.
1 to 5. All right, and that will leave me with 6 to 20. All right, so this is going to be the summation of k equals 1 going to 20 of my k squared. Then we're going to subtract off k starting at 1 going up to 5 of k squared. Right? Because we only have formulas that start at 1. So that's why I have to take off the front part. All right, so again, my k squared formula is this one down here. N times n plus 1 times 2n plus 1. N times n plus 1 times 2n plus 1 over 6 minus another one of those. All right, so when I plug in my stuff, for this first one, what's going in for n? 20, so it's going to be 20 times 21 times 41 over 6 minus, what's going in for my second one? 5. 5 times 6 times 11 over 6. All right, so down here, let's see, this will cancel with this, and I'm going to get 3 left over. Up here I'll have 10, but the 3 will cancel with the 21, leaving me with 7. So I'm going to get 70 times 41.
Oh, I have
41 times 70. That's going to be 2870. Minus this one, those cancel, so I'm going to get 55. So I'm going to get 2815. America.
I got 11,260.
If I'm not 100% that's correct, this looks pretty good to me. I definitely got 20 times 21 times 41. Right, the 6 canceled and left me with the 3 with the 20. But the 3 canceled with the 21, leaving me with 7. 70 times 41 is definitely 2870. Yep. And then this one has to be 55, so I don't know. I would check it out. All right, kind of makes sense?
Yep.
All right, the properties are actually not that difficult, as long as you have them in front of you, so you don't have to memorize those formulas. Other than that, kind of like plugging and chugging. Homework, 18 through 36, only multiples of 3, and then try 71 through 82 all.